So good morning, ladies and gentlemen. Welcome back to our Unit 2. This is primarily that's going to be on your next test, test number 3, on rational expressions. The connection, what you're going to be looking at, I'd like to explain. It's like rational numbers. What's a rational number, really quickly? It's a fraction that's written as a over b, where b cannot be equal to 0. Right? Where a and b, of course, are integers, right? A lot of you already know that from grade 9. So rational numbers, fraction, rational expressions, they're going to look kind of weird. However, the key thing that you're going to be stressing in this whole entire unit is actually this b not equal to 0, or specifically when the denominator goes to 0. A lot of you know the internet meme, maybe dividing by 0. Oh no! Worlds collide, universe implodes. All good things. So it's an internet meme that's saying dividing by 0. In math, it causes a lot of people problems. Right? So we don't like dividing by 0. In fact, we cannot divide by 0. Right? So that's the big idea. The second part is we call this known as stating restrictions. So for example, basically for a rational expression, let's give you an example. 2 over x plus 1. This is called a rational expression. It's not a rational number. The 2 is a number, but this x plus 1 is a binomial, x plus 1. We don't know what x is. And the way that you're supposed to kind of ask yourself, what could x be? X could be any number, right? Everyone agrees it could be like a 3, it could be a 7, it could be a negative 2, it can be a fraction or a decimal. There's a problem though. There's only one number. A lot of you already are understanding. There's only one number that would make this denominator approach 0. Anybody want to tell me what number that would be? And it's relatively easy. Danielle? Negative 1 is correct. If x was ever negative 1, and let's just break this up, let's be silly. If x was equal to negative 1, then you would get this expression 2 over negative 1 plus 1, which is of course 2 over 0. Which again, by definition, is not a fraction. It's not a rational number. This is bad. Math people hate it. Math people hate it. So, if I were to ask you then, what is the restriction? You would simply say for this question, the restriction would be x cannot equal to negative 1. And notice, you've seen this already, because it's an inequality that you kind of understand. One more time, x can be any number except with this restriction. Okay. Sometimes in algebraic expressions, there are no restrictions. Let me show you an example where there's no restrictions. Let's just say we have x minus 2 over 5. This is a rational expression, everyone agrees, because again, we have a binomial in the numerator, but this is dividing by 5. Don't get me wrong, a lot of you actually understand this, I think. It's just, some of you just got to wrap your head around it. We're thinking of what can x possibly be? Well, it could be any number. It can even be, if x was equal to 2, a lot of you understand this, 2 minus 2 over 5, 0 over 5, no offense, but if you got this on a test, what is your mark? 0, and 0 is an answer, right? Whereas this example, 2 over 0, this is actually called undefined, indeterminate, right? We cannot answer 2 over 0. If you try to calculate, you're going to get a math error. With 0 divided by 5, it actually gives you an answer 0. It's not a mistake, right? So in this case, there are no restrictions. Let's just pause there. Everyone okay so far? Any questions about this idea? This is the crucial thing so far, stating restrictions. Stating restrictions. And just to say analogous, that a lot of you know this from grade 10, and in fact in our max min word problems or even our quadratic unit, a lot of you think of these as like solving for the roots or zeros or x-intercepts. The only addition that a lot of you use is put a not equal sign. Let me show you what I'm talking about. In the next example I'm going to make up before I look at the problem, and I'll move this over. See it? Sorry, Maria. Let's just say we have this expression, x plus 3 over x minus 1 times x plus 5. Notice I'm not asking you to expand it. Now you're already seeing that the numerator seems to be a binomial, the denominator seems to be in factored form. Let's see if someone actually can tell me. Really easy. There's nothing really to do right now. Just tell me what are the restrictions. Let's get someone else that hasn't participated today. Is that okay? So maybe Alex or Sanaz or Bridget, maybe or Audrey or Eric. Anyone want to tell me what the restrictions are? Because again, the whole big idea is we do not want to divide by 0. So again, to lead you, we're looking at the denominator. Any volunteer? Brandon, your hand up?
Yeah.
Sure. What's the restrictions?
0.
0 is incorrect. If x was 0,
1.
okay, so let's just stop. It's not always going to be 0, but if x was 0, we plug 0 to here, that'd be -1. And plug 0 to here, that'd be 5. -1 times 5, that's a real answer. Everyone agree? A real answer. It's not 0. But if x was 1, this would be 0 times 6. 0 times 6? 0. 4 over 0. We can't about it. That is one restriction. There is another one though. Saba.
-5.
-5 as well. So x cannot be 1 or -5. Before we continue, everyone okay? Finally, a lot of you realize what we're going to be doing. Let's just lead it to the harder one before we start looking at the worksheet. Let's just say we had something like this. Notice in the numerator, even though some of you are saying, what do we do here? But we ignore the numerator for now. Right? So let's just say we're going to give you this question. X plus 1 over x squared minus 5x plus 6. This one is not so obvious. But some of you already know, maybe what should you do? Any volunteer? Flora?
You should first factor.
Probably factor, right? In fact, factor the numerator, well that's already done, that's x plus 1. And this one's actually pretty easy, right? Do you think you can factor that, Flora?
Okay. X minus 2. X minus 3.
Before we continue, everyone okay with the factor? Different volunteer now, please tell me what are the restrictions for this question? Audrey.
X equals 2 and x equals 3, which
Sure.
not equal.
Nice. Everyone okay with that? And again, some of you still do the mental check by plugging in the 2 and the 3 in the question just to make sure the denominator does go to 0, even though that's not what we want to do. We don't want to divide by 0. But that is a concept that a lot of students tend to do. They kind of check to see, does this denominator go to 0 or not? So let's take a look at the handout. Now I think you guys understand what we're trying to do. I'm going to just really quickly read it through. I'm now going to end our lesson by the example 1, because this idea I think is important, stating the restriction and understanding how to deal with it. And obviously we're using the rules of fractions, right? Obviously tomorrow's class, which you're going to miss, well not miss, but you'll see the video, we're obviously going to teach you how to multiply and divide the rational expressions. And then on Monday, we'll teach you how to add and subtract rational expressions. And then on Tuesday, also add and subtract rational expressions. And that's your test. Does that make sense? So your whole this unit is actually fairly short, but don't panic. When I see you again on Wednesday, and again, that's why Sab was asking, if you want to get these sheets for me, if you're here tomorrow or if you're here on Monday, I can give you physically, but they will be posted online. Okay? So again, the first part, it says caution, reduce where possible, always factor first, check restrictions as soon as you factor. And I'll talk about that in a moment, but let's do example 1A, B, C, and D, and that'll probably be it. I think you can follow along, even though example 2 talks about multiplying and dividing. If you want to go further, you can, but that's what I'm going to explain and give more examples tomorrow's class, the cohort B. So let's take a look at example 1. And let's give you the rules right away off the top. Here are the rules. There's only 3 straightforward rules. 1, factor first. 2, once you've factored everything, state restrictions, if any. And then 3, you simplify. What does simplify mean? You'll see in a moment. Okay? Notice we always take a look at the original question. In this case, example 1, we have x over 2x squared minus 4x. So, first rule says to factor. The numerator has been factored, because we don't want to do anything. Denominator, I think everyone agrees, there's a GCF of 2x. I get a different volunteer to tell me what's going to go in the brackets once I've taken out a GCF. Grace?
X minus 2.
X minus 2 is nicely done. So we've done this first. Everyone agree? Factoring first. That is why you need to know how to factor. Now, honestly, these factoring questions, they tend to be easier than the factoring questions that I gave you at the beginning. Tend to, not all. I haven't go from all of them. Now we state the restrictions. I'll leave you. Everyone can give me this one, I think. But for some reason, this one, some kids get confused. But Maria, you want to give me the restrictions?
It can't be 2 or 0.
Nicely done. For some weird reason, everyone can see the brackets because they say, if I plugged in 2 here, 2 minus that is 0, that's easy. What the hell? Oh yeah, that could be 0. That's why one of the restrictions, it actually is 0. Before we continue, everyone okay? If you really need help to see this, I'll just do this off to the side. Some students see it a little easier like this. Some of you find it easier, x minus 0. And that's that. Before we continue, everyone okay with the stating restrictions? That's the crucial one. But once everything's factored for, a lot of you remember, maybe from grade 9 math, we actually start dividing out or reducing. So hopefully you don't need to include that. That's what you're supposed to do. X in the numerator becomes 1. X in the denominator also becomes 1. The final answer, I think everyone agrees, is 1 over 2 times x minus 2. Now a good argument some students say, but Mr. Chen, when we see the final answer, Maria's answer of 0, what are you talking about? If x was 0, that would be negative 2 times 2. That's not going to 0, but we're always referring to the original question. That is why, notice where I put the restrictions. I tend to put it right beside. You can definitely put it afterwards, but I want you to understand, when we state restrictions, we're always talking really about the original question, never really with the final answer. Any questions about this example? Laura?
Not regarding this example, but let's say if we have x minus 2 at the bottom, what if we also have it in the numerator?
Yeah. Let's do that really quickly. X minus 2 in the numerator, x minus 2 in the denominator. First of all, let's get the restriction. Restriction for this? Eric? It can't be 2. X minus 2 divided by x minus 2? 1. That's the answer. With that restriction, it can be any number but 2. Any number. It can be 2.1. It'll be 1 though. It'll equal 1. It'll be simplified. Right? Because a lot of you already know that 5 over 5, that's like a test. I got perfect, 100%. Right? 100%. Laura again.
Yeah, but then technically 0 divided by 0, they also make sense.
0 divided by 0, unfortunately, is, hopefully you talked about this. 0 divided by 0, notice the denominator is 0. The answer for this, the answer is not undefined. It's called indeterminate. 0 over 0, you can't answer. It's not 1. I don't know the answer. This is actually the answer. Indeterminate.
Can we say infinity?
No, it's not infinity either. I'm not lying. It's called indeterminate. Good question, hold on.
Why wouldn't it be 0? Because if you divide
It's also, that's not correct either.
why
It's
not?
not, it's called, I don't have, this is rich math. Normally I have time to do that.
Okay.
but, I don't.
That's cool.
I think you should, or you might wanna watch a video on 0 divided by 0. Okay? It's actually kind of neat. I just don't start, so I don't have that time. If this is like the regular, like regs, for sure we have time. I don't. Okay, let's do example B quickly. So we have 3y minus 2x over 4x minus 6y. And this one's trying to mislead you a little bit. So it's not always a binomial. If you're at home, you can see this. Yeah, see it. Any volunteer want to take a stab? We're supposed to factor first. I don't think there's anything in the numerator to factor. Grace?
The common factor of 2.
In the denominator, right? So it's okay if I rearrange this. I'm going to put 2x plus 1. And then take out a 2, you said?
Yeah.
And what are we going to get?
2x minus 3y.
Now, some of you are suspicious, and this is why this is here. I actually see it. It seems like there's nothing to do, right? That's why I like changing this up. Anyone see something suspicious that we can do maybe in the numerator? I'm trying to lead you. Alan, do you see it? Notice this is negative 2x plus 3y,
Yeah,
but this is 2x minus 3y. Oh, Bridget, you have an idea?
there's a negative in front of it,
So what do you think we can do?
factor.
A negative 1, right? This is why some of you remember with the factoring, and it's kind of confusing, like on the first day. What the hell, Chen? Why do we have when do we divide by negative 1? What's going This is that stupid example. I hate these. But Bridget noticed, and Ellen kind of, these are related, but if we factor in a negative 1, and I'm just taking negative stuff. You don't always do this, right? Sometimes you just leave it, but we get negative, we get 2x minus 3y over 2 times 3y. So we've done the first step. We've now factored everything. We're gonna agree? I just took an extra step. Some of you might just go from this right away if you see it. And that's amazing. Here's where I'm gonna help you guys out with the restrictions. So just listen up. One more time. To help everyone out, I'll do this in blue chalk. Some students will take that factor, that 2x minus 3y, and just like in grade 10, make it equal to 0. Right? Don't get me wrong. I know you're not supposed to do it because we don't want it to be equal to 0. So fine, put that in. That's fine. So then solve for one of the variables. It does not matter, right? Can someone just choose for me? You have 50, doesn't really matter. X or Y? Which one would you like me to solve for? X. So we'll add 3y to both sides. And then divide both sides by 2. Ladies and gentlemen, you just told me that is the restriction for this question. And that's what's so uncomfortable for a lot of you. But I think for enriched students, you actually understand this. In this case, it just can't be 3/2 of y as one of the restrictions. If it was ever 3/2 of y, and you plug that in here, this would go to 0. Everyone agree? I understand we don't know what y is because it's a variable, but who cares? Does that make sense? So this is actually a restriction. So some students will actually do this. Don't get me wrong, unlike in this one, or the example that Flora asked, many of you are just doing this in your head. Which gives us this. Everyone see that? These ones tend to be easier. And the same approach happens here. So don't feel bad if you had to do this. However, let's set someone to help us out. Alex, do you think we can divide anything out, simplify now that we've done factoring first and stating restrictions? Do you think we can divide anything out here? Take a wild guess.
We can factor the 2x minus 3y.
Yeah, he's gonna say factor, he's meant to divide out, right? So we can see this 2x minus 3y, divide out this whole thing. Before we continue, everyone okay? What's the final answer? No pressure. Danielle. Negative 1 over 2. Sorry, I'm running out of room. With that restriction. So just like Laura's question, hey, the algebraic expressions, they divide it out. Negative 50%. Don't grab that. Don't grab. Any questions about example B? You just have to try it yourself too again to make sure you know how to do it. We're almost there. Shoot, I remember something. but now I can't remember. I'm getting old. Oh, can I do a silly question before we do example C? And maybe I'll stop at C if that's okay, because unless someone wants to do it. Let's do extra example. I kid you not, we still have some students doing like this. They think they can do this. To simplify this question, watch what I'm going to do. 2 plus 1 over 3 minus 2. And this is what some kids do. This is, by the way, I'm going to show you this as well. Watch what I'm going to do. Yeah, I see a 2 here, I see a 2. Well, let's just get rid of those. Yeah, get rid of those. I get 2 over 2. That's 1. What? Score.
What?
But this is wrong. Everyone agree?
How'd you get 2 over 2?
Yeah, they're noobs. No offense online, you're not a noob, you're my students. Because a lot of you realize this 2 plus 1, right. 2 plus 1, 3. 5 minus 2, 1. That's 3. 1 and not the same. Everyone agree? One more time, a lot of students realize this. You can't start dividing out everywhere you see things. You can only divide out the factors, or things that are being multiplied. Everyone agree? Multiplied. Multiplied. That's why this is technically, and that's why we have to use the brackets. And that's why Alex knew that 2x minus 3y and that 2x minus 3y, they're identical. We can divide out this expression and divide out this expression. And it simplifies to this. Before we continue, everyone okay? I apologize for showing that, because now that I've shown you, and Eric said, someone actually did it. Now that I've shown it, some of you might, I've seen it! I'll do that on my test! Don't do that. Everyone okay? Can I erase this?
How'd you get 2 over 2 though?
Because some kids are silly. 1 plus 1 is 2.
What was this?
3 minus 1 is 2.
Okay.
Am I? Am I? Everyone okay? All right. Audrey, what?
I was saying it just messed us up more when I was kidding.
It wouldn't make sense if it was like multiplying instead of
Adding or subtracting.
That's what you do.
Yeah,
Yeah.
that's what everyone agree. I'm trying to highlight this.
Yeah.
When you see things in the numerator and denominator. All right. That's right. All right. Last example for today's lesson. I think it's okay. This question C. But this time, hopefully, some of you will help me out. And that's what I'm trying to explain. We don't start just dividing up the x squares, right? Like 10 and negative 10 and 15. Hey, 5 moves. Don't do that. That's the whole point. So now, do you think you can factor the numerator? If you get it wrong, it's okay. I know I'm putting you on the spot. Take your time. Do you think you can factor the numerator for me? And someone else, maybe, I don't know, Brandon, if you don't mind factoring the denominator? Just take your time. Just factor it. Because that's the first step. Hopefully everyone understands what I'm trying to do. I like keeping this in notes here. So now, do you actually have the numerator factored out?
X minus 2.
Sorry, x.
X minus 2. And then x plus 5.
I think she's correct. Everyone agree? Yeah, nice. Way to go. So easy, right? Don't get me wrong. It's harder once you see a little difficult. Brandon, do you have the denominator? No pressure.
X plus 5 and x plus 3.
Nice. Before we continue, anyone's still having difficulty with factoring? Again, this is an easy one, but when you do the examples, they'll be there supporting you. Second step, state the restrictions. Notice again, you look at the denominator, not the numerator. Look at the denominator and tell me if this would approach go to 0. Eric, want to give it a shot? What's the restrictions?
Minus 5 and minus 3.
Minus 5 and minus 3. Just to give you an aside before we finish up, by the way, it is correct. On a test, you say, Mr. Chen, he's so old, he doesn't know what's going on. I'm going to go, I don't know, like add on -7, 2, 1/2, J, Q. He doesn't know what he's talking about. If you do this, like give me the shotgun approach and hopefully guess numbers, you're obviously going to lose marks. It just doesn't mean you know what you're talking about. Like if you were going on a date and you say, hey, I'm dating, hey, what's your name again? I don't know, let's just say something. John, Jim, Mary, Luke. you're gonna get in trouble, right? You gotta know the answer of the person you're dating. Back to this. We're almost there. Dividing out or simplifying. Any volunteer? Easy peasy. All right, Sal.
X plus 5.
They divide out, correct? What's our final answer then, Sal? Let's say it.
X minus 2 divided by x plus 3.
Notice she did not keep thinking. She did not continue dividing out the x's. This is the answer. That's how you say it. In terms of what it looks like, I don't really want to tell you what it looks like. But for now, that's what we're practicing with simplifying rational expressions. We only did 3 out of the 4 examples, but I think you can figure out example D. Go online, check the PowerPoints, and that's it for today. Continue working along, and we'll see how it goes. Okay, I'm going to stop the video.